The other part of lesson 96 involves direct and inverse variation, which we've done before. All right. I'm going to give you a new technique for this. This is actually not a new technique, but it's inverse and direct variation. It's combined variation is what this is called. I believe there's a joint variation on one of them too, maybe.
Yeah.
All right. So this is called combined variation. The other one's going to be joint variation, which might be mixed with combined variation. Basically, what's happening is more than one type of variation is happening in the problem. All right. So notice this: the number of girls varied inversely as the number of boys, and directly as the number of teachers. So there's an inverse and a direct variation going on all together. The two techniques we've learned for variation problems is the constant type, or constant variation technique. We use K for constant variation, and we did the equal ratio technique. I'm going to show you this problem with both techniques. You can pick and choose which one you like better. I don't care which way you use. Give me the right answer using a valid technique. So, if I'm doing this with the, let's go with the K technique first. All right. So, the number of girls varied. So as soon as I see these words, it immediately becomes G equals K. G for girls, K for constant variation. All right. Inversely is division as number of boys. Directly as the number of teachers, that's multiplication. So you don't make up a separate one for each one, you just put it all together into the same expression. It's direct teachers, so teachers being multiplied, inverse boys, so boys gets divided, and again girls varied, so girls equals everything. Right? That gives me 4 variables, 3 of which should be known at one moment in time. So when there were 50 girls, there were 20 teachers and 10 boys. So at one moment in time, we know the exact number of each of these categories, girls, teachers, boys. We don't know what the constant variation is, so we substitute everything into the expression. So 50 girls, K we don't know yet, there were 20 teachers, and there were 10 boys. 50 equals K times 20 over 10, which means that 50 is equal to 2K. 20 over 10 divides by 2, right? Divide both sides by 2, we get K is equal to 25. Once I know what K equals, that's this K right here, that's the constant of variation. A constant does not change within a problem, so once we know what it equals, that's what it equals forever. So my equation up here becomes G equals 25 times T over B. And then we go on to the next statement, which says, how many boys were there when there were 10 girls and 100 teachers? So we don't know boys, but we know girls and teachers. So 10 girls, 100 teachers over B, which we don't know. I'm going to put this over 1 just to create a proportion. If I cross multiply, I get 10 times B equals 2,500. Divide by 10, we get B is equal to 250 boys. All right? That is the K technique, and again, it works just like that every time. You create your statement, you put everything in to find K, you put K back in, put everything in to find what they're looking for. The equal ratio technique looks like this. Girls varied. G1 over G2 equals fraction bar. Inversely as boys, B2 over B1. So inversely we invert the subscripts. And directly as teachers, T1 over T2. Directly the subscripts stay the same. So just everything that happens. Inversely is this, directly is this, inversely is something else, directly is something else. Just anything that's inversely, you invert the subscripts. Anything that's directly, you put the subscripts in the same manner. And that gives me 6 pieces. First, 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 second, second, second. We fill in all the information we know. So the first set of girls was 50. The first set of boys was 10, and the first set of teachers was 20. The second set of girls was 10. The second set of boys was unknown, and the second set of teachers was 100. So you substitute everything in that you know, and then it's just a cross multiply problem. You can reduce it a little bit if you wish. As far as reducing, this 20 chops that 100 down to a 5. That 10 chops that 50 down to a 5, and that's a 1. I cross multiply now. 1 times B2 is equal to 5 times 5 times 10. There you go. I prefer this technique myself. Okay. I learned this in high school. My teacher never taught me this in high school. I learned this through this book. It's one of the few things this book has contributed to math, in my opinion, that I like better than other stuff I've learned in the past. But I like the fact that I get a structure, I put the numbers in, I get the answer immediately, instead of having to go through a middleman. I have to find K to find what I'm looking for. So I kind of like this technique better. They both work, so take your pick. Get good at one, if not both. Okay, but again, for me, I like this method better. You guys are welcome to use whichever one you want to use.